introduction short, but in general, I'm here to ensure that from pre-K to 5, and from the jump from 5 to 6, the math is all aligned. We've been teaching conceptual math at this school for easily 10 years. That hasn't changed much, but we have listened and parents have asked for more explanations of it. Today is going to go at quite a fast pace. Your kids, first of all, learned some of these skills last year, but we're upping the ante. We're getting into bigger numbers. They also, this is about a 6-week unit for them, and you get 50 minutes. So, there's no test at the end. I'm not expecting mastery. What we're hoping to do is give you an idea of what's going on in class so you can have conversations with your children. We know that parents are the first teachers for their children, but at times, once they enter school, it's best if the teaching of the math happens in the classroom first. So please don't take this packet home and try to pre-teach your kids. It just doesn't work real well. If they could get the full experience, the nice exposure in class, and then when they come home, you can support what they're doing. And if you don't understand, you can always simply ask them questions. This packet, if you've been with me before, I keep adding more and more information to the packets because you get to tell me what you want at the end, and I do try to listen. So I'm just going to show you quickly. Here's my email address. You're welcome to email me at any time. This address, which is pretty horrible to copy into Google, is a parent resource. It's called ASD Parent Math Resources. It's connected to a site called LiveBinders. You're better off Googling it and looking for that than trying to put in the URL. And on that site, we have this packet. We have a copy of this session today and our previous sessions and the answers, because we will not be doing all the questions today, and there are those of you who will want to double check your work. I'm going to quickly show you. I've given you a vocabulary page that I'm not going to worry about as we talk today because I'm here and I can explain it. This vocabulary is not particularly vocabulary that we are expecting your children to use. They'll use regroup. They'll probably use the word sum, which is the answer to an addition problem. Add end, I'll be honest, possibly but not likely. But we use them in class and some kids like it. I mean, they can learn all the words of dinosaurs, they can use the words of math, but that's not our goal. I wanted to refresh your memory of the commutative property of addition. That just means we can add that adding 3 plus 2 is the same as adding 2 plus 3. And your kids use that a lot. We are not teaching it to them as a property, but we are teaching it to them and proving that it works. I'm a math geek. I do not even use minuend, subtrahend, and I do use the word difference. However, when we start explaining things on paper, I realize how important those words are. So they're used in this packet for you simply to understand something, not an expectation that you're going to start using this language or your kids. Decompose is a word you're probably familiar with. It's the breaking apart of numbers. 110 becomes 10 ones. 100 becomes 10 tens. Understanding that strategy is paramount for having flexibility in computation. And then friendly number, that's not a math term, but it is what we refer to all the time. There are numbers that we can deal with much more easily than other numbers. 19, not a friendly number. 20, very much so. So can we manipulate our problem so we can use 20 and then adjust at the end if the question had 19 in it? And that's that flexibility that we're talking about. The next 2 pages, I'm going to show them to you and ask you not to really look at them. These are the explanations of what we're doing today in writing. We're going to do them. It's better off to be exposed to them by doing them, but this was the request from parents, is that they would love this cheat sheet. It went home similar on a parent newsletter that you should have and keep handy. This is the same things, but possibly in a different order. So we have addition, and we have subtraction. We have a few little things as to why they might be a better strategy or not as good a strategy. But those you can look at your leisure this afternoon. We're going to be doing a lot of this, so I'm not going to go through them one by one. That's really not the best way to teach or to learn. So I'm going to jump in. We're going to be looking at a lot of strategies today, so we're just going to get going. I'm going to tell you and inform you kind of where your kids are versus you. Remember, you're coming in pretty cold. They've been doing math daily with their teacher all year. So by second grade, they have seen the arrow method. And the arrow method is really a notation method of writing down what they're thinking. This one was new to me several years ago, and it solved a lot of our problems of the kids, but I did it in my head. Show us what you did in your head. And this is a shorthand way of writing that they can show us what they were doing in their head. We want them to continue using that mental map, but we do need to know what they're up to. So quickly, the arrow method just says, it's what I'm doing. So this first problem says, if I have 39 and I added 1, what would I get? 40. This is how simple a notation we're talking about. So 56 plus 10, 66. Did you finish the last two? And you notice that those all of a sudden became subtraction. What do you need? Yeah. So these that you just did, those were really first grade level, what we were having them do. It's just a strategy that they can start using to solve larger numbers. They're going to decompose the numbers, add them the way they see how they broke apart the number to get an answer. So if we look at this, 36. They hold the first 36. They broke apart 23 into 20 plus 3, and now they can add the parts fairly easily in their head. So we've got 36 plus 20 is 56, plus 3 more is 59. What would I probably add first to the 43? 20. So we get 63 plus 1 more is 64. Could I have added the 1 first? Absolutely. Could I have broken the 20 into 2 10s? So this is where it comes up to the child, and this is going to be up to them where they are in their fluency of adding. So one child can break it apart to 20 and 3, another one might do 10, 10 and 3. And we'll see some reasons why we might break it apart even more because of crossing a 10. So 57 plus 19. Probably going to start with the 57. What would you add next? Okay, let's do 10. We get 67. Yes. A lot of kids would add 3 next, because that gets us to the friendly number of 70. Now, they took 3 of the 9, and they have 6 more to add, so they get the answer 76. So we're no longer just decomposing numbers by place value. That's one of the strategies. The other strategy is to break apart the numbers to help us get to that friendly number along the way. And this gets us past this regrouping and carrying of 10s. I was in 2 second grade classes yesterday with kids explaining this to me. And they were coming up with it was amazing how individual they did it, but the fluency was what they were able to do. I mean, they saw it in their head, their way, and they were able to explain it. Now, I also want to show you what you can do with this one. I wish I brought 2 different color pens, I didn't. This could also be 57 plus 20. That would give me 67, but I added 1 too many, so I have to take it away. And I wrote that, so it would be 77. And then I would get 76. this is where this strategy is a little bit different than a number line. We're always kind of moving to the right, and the notation above tells us whether we're adding or subtracting. On a number line, you're going back and forth, moving to the right if it's addition and moving to the left if it's subtraction. This makes it, for a lot of kids, a little bit friendlier and easier for them to read. Not all kids, some kids like the number line when they understand which way they're going. But that's really the little bit of a difference, because otherwise they are very, very similar notation. Yes?
My daughter was doing a subtraction the other day, and she kind of started that, so instead of taking 65 and going down to 48, I mean, it was different numbers, but she did it the other way around, went from 48 to 65.
Oh, adding up.
Yeah, so I was a bit unsure whether or not it was actually all right to have that kind of mindset.
Right. My first answer is, did she get the right answer? It's all right. Secondly, yes, adding up is a very, very strong strategy to use. We do show them problems where adding up is better than, or I should say, we show them problems where adding up is not such a strong strategy. We're going to get to that, but in general, adding up is really good when the numbers are close to each other. But if you're subtracting 68 minus 19, that adding up, there's a lot to do there. So we talk about the strengths of the different strategies, but it really, or I should call the efficiency of them. But if your child is getting it right that way in a very fluent manner, then that's a perfectly good strategy. So we'll do a few of those. And so for subtraction, you can see that there's two samples. But I would like you to solve at your table 84 minus 53 and 72 minus 58. And I'd like you to try to break apart the numbers a little bit differently. Try it one way and then try it another. And please, you're welcome to talk. In our school, a silent math room is not good. We know that learning is a social enterprise, and having to explain yourself is what makes it go into long-term memory. You're supposed to talk. In 5th grade, I made them use pens.
So you know the last 3 and then the vacancy it just depends on the kids how they learn by we're just
She did both of this value and I mean,
10, and then they count. Yeah. And then they count. Do I have 10? Some of them aren't. Yeah.
Okay, so this is called the arrow way or the arrow notation. It has a name just so we can talk about it. That's not particularly a math vocabulary word, but we do know that in order to communicate with each other, it's nice to have labels on things so we can, a child can say, oh, I did it the arrow way, and then I'm prepared to understand what they're going to do. So we're going to move on from that. That's simply a computation for addition and subtraction. It works in single digits, it works in double digits, it works in triple digits. Probably starts losing its efficiency in triple digits. It really depends on the numbers. Also, children are welcome to start with the 57 or the 19 because of that commutative property. Usually they're going to grab the larger of the two numbers in addition. Obviously in subtraction they can't. Well, they could write it down as adding up and they would start with the subtrahend. So we're going to put arrow way away, and I would like you to take 5 cubes of one color